This video will cover the second half of the handout from section 3.6. We're going to cover the use of DeMorgan's laws. So I'm going to scroll down to the second part of this. And here are the rules for DeMorgan's laws. These are laws that allows us to negate an and statement as well as an or statement. So if we have as a number one, the negation of P or Q, we can actually negate both the P and the Q and flip the and sign to an or. So we have the negation of P or negation of Q. So it's essentially distributing the negation to each letter and flipping the sign in the middle. In number two, we have the negation of an or statement. The negation of P or Q is equivalent to the negation of P and the negation of Q. So in each of these cases, we're distributing the negation and then we're flipping the sign. So we'll do some examples. This is number one. Use DeMorgan's laws to negate the following statement. Number one, I went to the bank and the grocery store. To negate this, we're going to say I didn't go to the bank or I didn't go to the grocery store. So what we've done was negate both statements and flip the and to an or. Number two, I'm going to Los Angeles or San Francisco. To negate this, I'm not going to Los Angeles and I'm not going to San Francisco. Number three, R and P. To negate this, using DeMorgan's laws, not R or not P. So what we've done was changed the sign from an and to an or, and then we changed the letters and negated both of them. And finally, number four, Q or P, we negate both letters, so we get negative, not Q, and not P. So we're going to do an example, another example. Here, we're going to determine which, if any, of the three statements below are equivalent. You may use information about a conditional statement's converse, inverse, or contrapositive, DeMorgan's laws, or truth tables. So let's take a look at statement A. I'm going to go ahead and enlarge this a little bit. Okay. Statement A says, I'm leaving and Tom is relieved or Sue is relieved. So what I've done is I boxed in the and here because it is dominant in the statement. And dominance comes from the word that comes after the comma. So that's what joins the two sides. So the first part is I'm leaving. I'm going to say that's P. We have this and sign. The second part is Tom is relieved or Sue is relieved. So the second part goes in the parentheses, Q or R. In B, I'm leaving, comma, and it is false that Tom and Sue are not relieved. So I guess you can call that a double negative because we have the word false and we have the word not. So it's a rather complicated statement. So we're going to put this in symbols. I'm leaving is P, and then it says it is false. So I'm going to use that negation sign to say it's false that Tom and Sue are not relieved. Well, that implies Tom is not relieved and Sue is not relieved. So I will say not Q and not R, okay? Because the word not is in there, all right? We already know that Q is Tom is relieved. So if we now want to say Tom is not relieved, we have to say not Q. And if Sue is not relieved, we have to say not R, okay? And we have the word and joining those statements, okay? So here, this is pretty convoluted. So I'm going to use is DeMorgan's laws. So what we can do is if we have the negation of two statements here with an and, we can flip it to an or and remove that negation, bring it outside the parenthesis and make it a Q or R. Okay, so that's what I've done. What was inside the first set of parentheses here, I turned it into negation of Q or R. And now we have this double negation, which is a positive. It's like that double negative I was talking about. And now we have P and quantity Q or R. And that is equivalent to statement A. So we now know that A and B are equivalent. Now we're going to look at C. If I'm leaving, then Tom is relieved or Sue is relieved. So if P, now we have this dominant comma, the word then. This is an if then. It's a conditional. So we use the arrow to show that this is a conditional statement. If I'm leaving, that's P. Then Tom is relieved or Sue is relieved, Q or R in parentheses. All right. Now that doesn't look anything like A and B, but in order to find out whether or not they are equivalent statements, I cannot use DeMorgan's laws because it doesn't deal with conditionals. So what we could do is use a truth table. That was one of our options in this problem. So let's use a truth table. We're going to set up statement A and statement C in our truth table, and we're going to build them up. So we have three letters, P, Q, and R, all right? And then we need Q or R, and then we can put it together and do this conditional and do this statement A, all right? So I'll just scroll down. We're going to set up our columns. We have P, Q, and R. And these are the two statements in the last two columns. We have statement C, and then we have statement A and B in the last column. All right. And when I break it down, I need this Q or R here. Okay. And both of these statements rely on that column. So now that I built up the top row, I want to fill in first with the truth table for P, Q, and R, all the cases. And so we know what we know about how many rows, how many different cases depends on how many letters we have. 2 raised to that many letters. So 2 raised to the third power, that's equal to 2 times 2 times 2, which is 8. So we have 8 different cases. And these are all the cases where either they're all true or they're all false or a combination of any of them. Okay, so once you fill this out, we're going to find Q or R. So Q or R is false only when both of them are false. Okay, so I'm going to annotate my screen. I like to use color or stars or whatever just to try to see which columns I'm looking at. Okay, and here's Q and R, and it's Q or R. And I want to see which case this is false. So we know that when both Q and R are false, the whole statement's false. So let's see, I'm going to go down here. Okay, here's one case where they're both false. Therefore, Q or R is false. And at the very bottom here, where both of them are false, Q or R is false. And the rest is true, okay? That's what that or statement means. If either one of these letters are true, right, either one or both, then we know it's a true statement, okay? So those are the only 2 cases that's false. All right, I'm going to clear my drawings and go to the next column. Now this is C here. This is column C, all right, and this is column A and B here, all right. So this is A and B. So let's get this one. C is if P, then Q or R. So I starred the column if P, then Q or R, so that's this fourth column, all right? Now the arrow goes this direction, so I can see that I'm not worried about these two columns here, all right? So if P, then Q or R. The conditional is true, right? So if P, then Q, I'm sorry, this is false only when the first part is true, so P is true, and Q is false, okay? The other times they're all true. So let's try to find that case in which P is true and Q is false. Right, so this is true, 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 false. So here is that case in which the statement is false. And then we have false, true, false, true, false, true, false, false, and the rest are true. The rest of these are true. Okay, so we only had that one case where the first part or the antecedent was true and the second part or the consequent was false. And the last column is P and Q or R. So I'm going to clear out all my drawings again, and I'm going to star those columns. So I've got my P, and I've got my Q or R. So it's the same two columns, but this time instead of an arrow, we're talking about the and statement here. So this is and. So what do we know about P and Q? So this is true only when P is true and Q is true. All right, so the first one, we have both of them as true, so we have true. The second one, both of them are true. And the third one, both cases, they're true. The fourth one is true, false, false, true, false, true, false, true, false, false. The rest are false. Okay, so we only have three that are true. Now what we need to do is compare the two columns. All right, so this is my C, and this is A and B. And it looks like they're the same until we get down to this row. And therefore, we cannot say that C is equivalent to A, and C is not equivalent to B as well. The only thing we can say about those three statements is that A is equivalent to B.